Well, good afternoon and thank you, and a very warm welcome to each of you to Isifundi Training and to another episode in our current series of Bite-Sized Corrosion, where we are celebrating women in corrosion and engineering. My name is Vanessa Seeley Fisher, and it really is my great pleasure to host today's discussion. This current series of Bite-Sized Corrosion is highlighting some phenomenal women in the industry. And if you missed the first few chats that we've had, please do yourself a favor and watch the videos on our YouTube channel. You'll get a front row seat into my conversations with Lerato Kenetsi, who is the senior engineer at the Muela hydropower station in Lesotho, with Dr. Janet Cotton of 180 Degrees, who undertakes really interesting corrosion failure investigations. I've chatted with Roxanne Canny of eThekwini Municipality, and she is so passionate about empowering municipal engineers. And Nomsombuluko Hadebe is highlighting corrosion and its prevention at Armscor Docks, which is just such a great field to be in. And today I'm joined by yet another phenomenal woman in the industry, Annalene Brown. Now, Annalene graduated with her master's in chemistry, and she's been using her expertise in the development of protective coating formulations and in providing technical support at BASF. With a passion for sharing her knowledge and expertise, Annalene is busy pivoting her career into education, where she will make an enormous difference at high school level. Annalene, we are so glad to have you with us today. Thank you.
Well, thank you so much for inviting me. I'm really excited to be here and be a part of the series. And I've watched a few of them myself.
Oh, thank you. That's lovely. So, Annalene, we always like to start at the beginning. And I wondered what first drew you into the world of chemistry and coatings?
So I was lucky enough to grow up on a farm. And my dad always encouraged me to ask the question, why? Why does this happen? And one of the things, like, he chopped down a tree and said, look at the rings and you can tell the age of a tree. So apart from being able to blow up things in science, I always enjoyed that you could learn by seeing and doing. And that was the biggest draw card, pretty much, for chemistry, I suppose.
And you started in chemistry. So when you went to university, you went, this is where I'm going to be in chemistry, or did you start off in another direction and then change?
No, not at all. So, well, I did kind of try to keep it broad. I was very grateful. I grew up in Zimbabwe. I did my A-levels. So I did maths, chem, and bio. Physics was a little bit more challenging for me. So I always enjoyed that. And then when I got to university, I was really grateful. I managed to go to Rhodes, and I was able to do biochemistry and microbiology, which I enjoyed. I will be honest, maybe the beer making project in the microbiology was more of a draw card. But what actually ended up, so I really enjoyed the pure science. So the chemistry for me was a draw card. And there's different parts in chemistry, but I enjoyed the organic chemistry. And I really think it's more to do because it was more of a visual. You can draw your reactions and that kind of stuff. And it was a lot more practical lab work. So that's why I enjoyed that, yeah.
I'm so with you. It's like speaking to myself because I also ended up in the organic line initially. And I'm with you. It's so real and practical and physical. Within your career path, choosing it in chemistry, did you find that you had a significant mentor or role model that you could be influenced by?
Yeah, so there was a few throughout, but one of the most, it was actually a fellow woman who's, I know as Dr. Klein, but she's now Professor Klein at Rhodes University. So she was my supervisor, and she definitely instilled the love of practical chem for me. You know, whilst we did a lot of research together, so I mean, I did my master's with her, she always stressed the importance of real life applications. So that's why for me, because I said to her, I was like, I'm not always going to want to do research or, do a PhD. And she says, no, because what you learn in your degree, you can, implement into the real life world. And that's what I did. So when I left university with my master's, I went and I worked for Plascon. So it was really nice to be in the lab. I literally went to bucket chemistry. So from the working with less than a gram and glassware to real buckets, it was a real change. But what I was really grateful for, it wasn't on the decorative side. I went straight into the industrial. So that was kind of like serendipitous. They needed a position in the industrial application. But because of my background, growing up on a farm, all that kind of stuff, I really enjoyed that side of things. And that's how I ended up there.
Super. So I presume just the very fact that you went straight into the coatings industry, being in the industrial coatings sector, must have been where your exposure to corrosion started.
Yep, that's exactly where it started. And it was quite a bit of an adjustment working with something that, like chemical formulas. And then going to things that were more brand names. So, well, I've done a bit of polymer chemistry, but incorporating my organic synthesis with polymer chemistry was really important. But it's almost like the coatings in the industrial side, they need to work. They're there to
Yes.
do a job, not just look pretty. So that for me, and it was to do with like a 2K formulation, and that was really nice. What I did enjoy more though is eventually my exposure to doing specific projects for applications, like in the
Right.
corrosion thing. Yeah, that's what it
Okay.
was.
So when you were, I understand that you were developing formulations, and
Yes.
when you were developing and testing them, presumably you were there to solve a specific problem. It wasn't just, oh, let's come up with a new paint for the day because it's a Tuesday.
Correct. So in industry, I would love to say that everything is driven by chemistry and how good something can be. But the reality is, also especially here in Africa, it's always driven by the needs, like a fit for purpose. So
Mm.
what your customer wants, what they can afford,
Mm.
cost, and the time it takes. It's always a sliding scale. So for example, having lab experience, it's a very controlled environment. Okay, so
Yes.
you can formulate, you can say that this is the performance of your product. But definitely after I had done a NACE course, actually I'd done a NACE 1, which I was very grateful that the company had allowed me to do that. I had the opportunity to actually go to the site and do testing at the site.
Mm.
And it opened my eyes. It's something that textbooks can never teach you. So for example, then learning, I mean, you always want your substrate to be cleaned properly in order before your coatings are applied. But once you get to site and you understand that the pylon that you need to protect is 3 meters high and there's no way you're going to get a blasting machine up there, never mind the health and safety practices that are associated with it. So it really opened my eyes in terms of like who you're making it for, fit for purpose, and the way in which it can be applied has to be all considered when you're formulating, and not just from a performance point of view from a chemical aspect. Yeah.
Yeah, that is very true. And I guess having highlighted those, would you say that those were probably the greatest challenges that you had when you were making new formulations, was actually to make them applicable to the situation? Or did you have a specific standout challenge that was the biggest challenge in the lab and the field?
So it is a challenge, but that's why it's really nice. Like for example, you work as a team, right?
Mm.
So you have the chemistry guys in the lab where we had the expertise, we had the sales guys, then you had the customer and the tech services. So it was really nice to be able to collaborate and make
Mm.
sure that that was the better way of approaching a situation. And also, again, at the end of the day, it is business. You can't make something too niche because at the
Yes.
end of the day, you need it to be sold. So sometimes you had to look at more of a general application that would be able to satisfy a certain amount within that scope of the corrosion protection that you were trying to make.
Annalene, just moving, sort of stepping back a little bit from when you started till now, how do you think advancements in coating technology, in which there have been many, how have they changed the industry? Have they changed the industry?
Yes. Interesting enough, so Vanessa, I've had a lot of experience in the coatings industry, and now having worked for BASF, there's different factors that drive, right? So for
Mm.
example, we're a European-based company, global footprint. However, so what drives it a lot is reach regulation. So although
Mm.
regulation might not be based in Africa a lot, so a lot of the products that are or the strategy in which we want to promote into the industry, that then goes into that advancement. So for example, like the ban of chromates and pigments, that
Mm.
was one. And then a lot of the synthetic pigments came out. And everyone, I mean, while chrome pigments give a lot of anti-corrosion protection.
Yes,
So
indeed.
when that went, you're like, oh, what's going to happen to that? A more recent one is now PFAS, which is the Teflon kind of thing. So for
Right.
example, in wax paper, it's thought to interrupt your endocrine stuff. So a lot of the regulation is coming in. So whilst there's advancements, there's also, you got to adapt to a lot of the regulation that is coming through. So what I really appreciate, like when I first started, a lot of people thought water-based products weren't necessarily the best in corrosion
Mm.
protection. because it's almost like counterintuitive. You're adding a water coating and now you're going to prevent water from rust, and the applications thing. So whilst there is limiting, in terms of C5 environments, the advancements in the water-based technology has improved in terms of what is able to. So what you'll find even in China, a lot of ships are now being coated in water-based products because of it fits for purpose, and you don't need to use the solvent-based stuff anymore. So there have been a lot of advancements, and I think it will continue changing based on regulation. Another big thing that's changing it now is sustainability, or what is claimed as sustainability, and again, what cost. So that will always.
And I think those will always be a juggling act. Environmental and human safety definitely need to contribute. And as we get better, as we understand more, we understand the risks associated, like with the chromates, the leads, and then we're challenged. And that's also the exciting bit, is that then back to the chemistry lab. And so we can't use that anymore. What alternatives are there? What new products can we manufacture? I think that is an interesting aspect. The other difficulty, I think, or maybe not difficulty, but thing that needs to be considered is that whenever we're talking about industrial coatings, protective coatings, ISO always enters the conversation. It's often there at the start with coating selection, even with categorization of the area that needs coating. But you've also been involved in testing coating products to ISO standards. And do you believe that these standards are critical in ensuring that the coatings actually do their job, or are the standards sometimes a detriment?
Interesting question. I think it's got a lot to do from where you're sitting. So perspective of the person testing it. So as the developing a coating, yes, ISO standards. I think it's always important, if you're going to have a benchmark, you need something to benchmark a coating against. Okay, and that's why I think standards are important. How applicable it is sometimes is a little bit more challenging. So for example, in South Africa, yes, there's ISO standards, but a lot of it is SABS. So depending on who's specifying the job is to what standards are chosen. And also to test ISO standards, it requires a lot of time. It's a lot of the time-intensive process. It is also costly, okay? And that's why you got to understand, it's very much project driven. You have to understand what your end goal is, and at each gate, what your coating will, so have it as a stepwise kind of approach in order to minimize some of the pitfalls that you might find along the way. But I do think it's really important to have ISO standards, specifically in an industry that I think sometimes in practice is not that regulated.
True. Yeah. Yes. Thinking back on your time in the lab, have you found, or can you recall any specific instances that you're willing to share with us where the testing might have revealed an unexpected weakness, and how do you go about fixing it?
Yeah, so I'm kind of grateful that I've now been on both sides of the table, lack of a better word. So now having been at a formula, in a paint company and now selling raw materials, because we did have a situation where we're testing a flooring coating and you do a dolly pull-off test. I don't miss those anymore. So, but all intents and purposes, doing it in a lab perspective, you can isolate where your failures are coming from. So we had a coating where we had done test methods and it reached a certain standard. And all of a sudden, the certain batches that we had come through for testing wasn't matching the standard anymore. It's not something you want, and that's why it's really important to do self-testing a lot of the time. So you don't always want your customers to be the one telling you that this is your product that's gone out. So it's always important to kind of keep check of your own products. Anyway, long story short, what ended up happening, it was a raw material in this coating that was changed. It was a similar product, different supplier, and that's where we could isolate it and then manage and fix it. I'm actually really grateful that it happened, because now being on the other side, what I was grateful for is that supplier worked with us. So for example, now being on the other side, if there's a complaint, being able to work with the paint company and being able to resolve it. Because let's be honest, a lot of the time, especially in corrosion protection, the projects are high value. And the length of the time in which this has to, the guarantees are a lot longer than a wall paint for Mrs. Jones, who might change in, next year when the fashion of the color changes. So the stakes are a lot higher. So in terms of understanding that, actually helped me in my current job. I wouldn't have had it if something bad hadn't happened on the other side, I suppose.
Okay, that's so interesting.
Yeah.
Now, shifting a little bit, the coatings industry is still very male dominated. How have you been finding your navigation through that over the years?
It is very more male dominated, but actually, funny enough, in South Africa, it's becoming, in terms of a sales perspective, there's way more females out there, which I'm very glad about. So it's very, very interesting that there's a lot more females in the industry from a sales perspective in the chemical industry, which is really nice to see. But yes, you're right. Like in terms of it is very much still in the coatings industry, male dominated from a manufacturing point of view. I'm very grateful. My time in BASF, I've had experience going to West Africa and to East Africa, and there you deal mostly with just men. It hasn't been a problem in the sense that if you are confident in what you know, if you stick to your facts and you have a lot of respect for different cultures, you come to a common understanding and able to navigate it.
That's very wise advice.
Yeah, I mean, like, yes, have there been times where you feel a bit awkward and then you realize that you are also able to sometimes just walk away about or keep quiet or, handle things differently with a level of maturity. So, but I think I was very grateful coming from Zim. I had a different experience to like having to deal like a make a plan kind of perspective. So when I was in West Africa, they have a lot of power cuts. So I'm able to relate a lot and understand. And I think that surprised them that I even understood like the generation of a power and like what KVI generator. And because I'm sure they read white woman, what does she know? And that to me doesn't bother me because what does she know? And until you have a chance to be able to discuss things, it's nice when people give you the benefit of the doubt, but it's also fine and nice when you win someone over time.
Yes,
so that's also fine.
Now, you've alluded to the fact already that you've spent more time recently as a technical consultant in the sales teams. Do you miss the laboratory aspects, or do you find yourself going back to the labs just to get a better understanding of the chemicals and their interactions?
Yeah, cool question. I was really grateful that that my roots are in chemistry and in a lab, because sometimes I was once told by a former boss who I really enjoy, he's now in the UK. He said to me, and I even asked him, I said, so why are you hiring someone from chemistry background and not a sales perspective? And he proudly said, you can teach a chemistry background person sales. You can't always teach a salesperson chemistry. So I was very chuffed to have that experience and to be able to also, because in order to sell something, you need to, I like to know more of the chemistry to be able to know it. And also now being out of the lab, you do lose a certain amount of touch with it. But being able to ask the correct people who are still in the lab and being able to have that conversation on a technical level does help. Do I miss it? Would I go back there? No. I think I like talking to people too much.
Well, it sounds as though you've spent a lot of time educating your client base, and that's a really wholesome thing, because I think going forward, the more education we have within the various sectors, the better understanding we have, and so the more likelihood we are to get success. So that's a great thing. Well done. Now you're changing. You're currently studying towards your PGCE or your teacher's qualification. And I'm intrigued as to what has inspired you to pivot towards education.
I am so excited. It is definitely a pivot in a completely different direction. So when I was at university, I was involved in a lot of science outreach. So for example, we have a National Science Week. It was actually in the beginning of August. This year, South Africa has a National Science Week each year. And I did a lot of outreach. And that was actually what I was wanting to go into. So for example, there's really cool science initiatives. There's a science center here in Joburg called Saibono. And that was my aim. And that's where I was wanting to go. But unfortunately, work, money, I have taken a longer route to get to teaching. And that's because I really do have a passion to share what I find interesting in chemistry, and it doesn't always come out of a book. And for me, it doesn't always, you don't have to be an A-grade student to do what you love, and And actually, in research, when I did my master's, the master you became is of not knowing.
Yes, yes.
Because the more you research something, the more things you find you don't know. Thank goodness it taught you a lot more grit and a lot more things than what a piece of paper can just tell you. And I think it's time I can share that with. So yeah, I want to teach high school students. I think it's going to be different stress. So less travel and more time with my kids at home, but I do think it's a different way of me being able to give back and show what is out there. And I think having now had work experience, my hope is that I'll be able to inspire someone that you can study science and not just become a doctor. You can study science and become like a normal contributing. There's science is different and can be implemented in different ways.
That is so inspiring. And I spent some time just recently in discussions with some university professors, and we were talking about the challenge, and it's an international problem, of encouraging students to go into STEM.
Science.
And I think
Correct.
with you in the classroom, these kids are going to stand no chance. And that's really exciting. Do you think that your coatings and chemistry background will influence the way you teach?
100%. I think it will, because I want to be able to. I mean, some science concepts are really hard. Okay. I'm very much more of a visual learner. So if you have something that you can see why you do it, or it's tactile and you could feel it, for me, that's a lot easier to remember than what like a picture in a book. So I do understand that like nowadays, there's also, I mean, resources are quite scarce, but you do not need such expensive equipment in order to convey certain chemistry, or not even just chemistry, like even physical stuff. Like kitchen chemistry is quite a big thing, and it's in the simple experiments that actually the biggest concepts can be conveyed. So, and what's really nice is that there's a lot of resources out there. I mean, the internet is your oyster nowadays.
Well, I always love to give it a punt, and I'll just encourage you and our viewers to visit stemulator.org. That's STEM for STEM, stemulator.org, which is a South African concept, an educational exploration adventure, really, to find out more.
Yes, I have. I've spoken to the guy who started it, and I really am inspired by people who just want to give back and show that it's doable by anyone.
Yeah. And just for our viewers to say, keep your eyes open, because we have an interview with Richard Gunderson coming out on our Engineering Thoughts series sometime in the near future, where we get really passionate about stimulators. So anyway, Annalene, I distracted there, but as we close off our conversation, I wondered if you have any advice to give young women pursuing a chemistry-based career, particularly those pursuing a technical specialization.
Yeah, I think be confident in what you know, be humble, and just try your best, but have fun doing it.
Yes.
Because there's definitely difficult things out there, but have fun doing it. It goes a long way.
It does. Thank you so much, Annalene. This has been a wonderful discussion. I thank you for being willing to share your story, for giving us great hope for STEM education. I would love to be in your classroom. I know that you will make a tremendous difference to the lives, and I'm certain that our audience have also really appreciated this conversation with you. So thank you for taking your time and spending it with us.
Thank you so much, Vanessa, for inviting me, and I'm really appreciative.
That's a pleasure. I encourage you to keep curious. Thank you for being with us. Good afternoon.